Good afternoon, class. In today's video, what I wanted to do is to do an example of momentum problems. This is going to be from the collisions homework set. However, these are not going to be problems directly from the collisions homework set because, as you can see, these two masses are usually supposed to be the same. And the reason I did that was to simplify the process. But since this is an example problem and all of the homework, all of the work that can be done is the exact same, what I figured I'd do is to do a little bit more of a complex example where the masses are not the same. So, given that, we have two cars, car A and car B, both of mass 1 and mass 2. They're traveling at each other, V1 initial, V1 initial this way, V2 initial going this way. We are going to assume that this way is positive. So when we do this, we're going to say M1 is 1, M2 is 2 kilograms each. V1 initial is 3 meters per second. V2 initial is negative 4 meters per second because this way is negative. And then we don't know what, we're going to say we want to know what V1 final is, but we're going to assume that V2 final is 0. We're going to assume that this car, when it collides, stops. So of course, the question is, what would be the velocity of this car, car A, after the collision? Now, hopefully you can kind of guess. If you've got two cars coming at each other and this car stops, this car is not going to keep going in this direction. It's going to go in this direction. And that's important. That's an important instinct to have, because if you work through your problem and you find that your answer comes out positive, you're definitely wrong, right? There's no way, because what that's saying is that this car stopped, this car went through this car and kept going. Which I hope that makes sense, that it doesn't make, I hope you understand that doesn't make sense. So, given that, let's get started in this. And notice that in this case, I noted that this is an elastic collision. In this one, we're going to do an inelastic collision. So, just keep in mind, I tried to keep the problems the same, but just to highlight the difference between an elastic collision and an inelastic collision. So, let's use, we have our formula for an elastic collision, and so I just take all of the numbers that I put in here and I plug them in down in here. So notice I'm again using the shortcut method. So then I get 1 times 3 plus 2 times negative 4 equals 1 times V1 final plus 2 times 0, because that's V2 final. So of course I can safely ignore the 1 and I can safely ignore the plus 0. So here we go. This will be 3 plus negative 8, so 3 minus 8 equals V1 final. Therefore, V1 final is negative 5 meters per second. So with that, and that would be a nice, simple answer. That's the end of the problem for an elastic collision. With an inelastic collision, then the problem becomes a little bit different, and the answer will definitely change depending on how everything goes. And also, one thing to note is at the end of this one, I'll make a little bit of a comment on which one you would actually prefer. So here we go. Same problem. It's M1 is 1 kilogram, M2 is 2 kilograms, V1 initial is 3 meters per second, V2 initial is negative 4 meters per second. We just don't know what the final velocity is when they combine, and they crash, combine, and move as one. So we're going to use the inelastic collision formula. And so it's almost all of the same work, especially on the left side of the equation. But the right side of the equation is now 1 plus 2 times, parentheses, times V final. So we get 3V final equals 3 minus 8. So of course, V final is being multiplied. So to isolate the variable, I need to do the opposite operation that's being done to it. The opposite operation of multiplication is division. So therefore, I will divide both sides of the equation by 3. So now I've got V final is negative 5 over 3 meters per second, which works. This is a good, this solution actually is a good solution. It works out. But the thing that I did want to comment on was not only do you have, not only is the answer vastly different from elastic to inelastic, but hopefully it gives you an idea of why cars, whenever you see cars in accidents, they get completely mangled. Like everything gets broken, pieces fly all over the place, and that the whole reason for that is to make a car crash inelastic. Because the more elastic it is, that's negative 5 meters per second. This is, negative 5/3. Like the difference between these two is extremely large. This one may not be survivable where this crash is. So in favor of survivability, that's why, then that's one of the mathematical reasons why car companies tend to make their cars, they design the cars to have inelastic collisions rather than elastic collisions, and leave those elastic collisions for bumper cars. So that concludes this video on how to do a collision example problem. Good luck in your studies. May the force be with you.